Aaron, you started to say that you now apply it, you're applying it to humans, live humans, not dead ones, to make them recover motor functions. How do you do that?
All right, so one of the techniques that is used in rehab centers in the last about 10 years or so is called body weight supported treadmill locomotion. What you do is that you support the body weight of the patient using a harness to the desired degree over a treadmill. The treadmill is equipped with a special robotic device that moves the legs, and when the patient is loaded onto the treadmill, load receptors are activated, and activation of these load receptors turn on the pattern generators that I told you about, and actually the pathways running from these load receptors in the legs to the pattern generators converge with the original descending pathways from the brain to the spinal cord, and the outcome in spinal cord injuries, the spinal cord is disinhibited due to a lack of inhibitory control of the brain. The excitability is higher, and for that reason activation of these sensory pathways just by touching the treadmill activate the pattern generators, and you can monitor the activity of flexors and extensors in both legs, and the pattern looks pretty similar to what we see in experimental animals in the absence of the descending control of the brain. So the patient can actually activate the program that is in charge of walking, and after several months of training on this device, if the patients are have incomplete thoracic injuries, they will be able to gain some ability to walk with the appropriate support, of course, but they'll have the capacity to initiate their own walking, despite the fact that the spinal cord is not appropriately connected to the brain.
It's like creating a bypass mechanism, in effect.
Actually, it's using the pieces of hardware that are still functioning to gain a better motor function. And actually, the outcome of it, in addition of training the muscle, increasing the muscular mass, increasing blood flow to the tissues, helping with preventing bone degradation in spinal cord injury patients, is actually some ability to walk and improve the motor function. When the injury is complete and it's at higher levels, it still has some beneficial values, but in case of incomplete thoracic injuries, a substantial percentage of the patients will have some ability to move around.
And we'll finish with that, and then we'll come back in your lab, because I'd like to see your lab.
All right.
So this is your lab?
Yes, this is my lab, where I spend most of my hours.
It's not very big.
No.
How many people work in your lab?
We are, how many we are? We are 5 now, or 4.
In this space?
Yeah, in this space, yeah.
And what is this apparatus?
This is the in vitro set for intra and extracellular recordings from the spinal cord, from isolated preparations of the spinal cord, and we recorded the electrical activity that is produced by the networks that are in charge of walking, swimming, running,
so
automatic movements.
When you showed that...
Should I sit down?
Yeah, sure. Yeah. Sit. I'll welcome home.
I feel at home, yeah.
Now, that means this is used when you did that experiment with the half of the animal leg that was done here.
Yeah.
And these, you need all this electronic
These are all amplifiers and signal conditioners and computers and stimulators, and they're hooked up together via this matrix, and everything is computer controlled during the experiments, and we collect the data and we analyze it, and this is where the physiological experiments are done. We have we have a microscope in a microscope room, the confocal microscope, where we do the morphology and the tracing and all these kind of things. And we have another setup where we do the fluorescent labeling and recordings with calcium dyes, the activity of neurons in the spinal cord, using fluorescence.
Well, that kind of thing you showed me, and I'd like you to talk about it, and we'll show it on the screen, where you really found the three pathways, the three major pathways.
Yeah.
Tell us about that.
We found that, first of all, that we found a region in the body that sends sensory innervation to the spinal cord, and it is a very potent and sensitive region. And if you touch it or activate it, the afferents, the sensory nerve fibers, enter the spinal cord, and they activate different types of nerve cells. And these nerve cells in the spinal cord, they're called interneurons. They project to the network that we call the central pattern generators, and these central pattern generators produce the program of walking. So we tried to follow the pathways all the way from the afferents to the lumbar region of the spinal cord, and we found several groups of cells that have to be activated by the sensory nerves in order to turn on the pattern generators and to produce movements under these conditions.
Now, when you have these pathways and you have more than one, is only one working at a time, or are they all working?
The nice thing about it is that there are several alternative pathways that can be activated to produce this rhythmic activity. If one of them is damaged, the other one can take over. And actually, each one of the pathways that we studied is capable of transmitting the information that is required to turn on the pattern generators when the rest of them are inactive or lesioned or injured. So there are many ways by which it is possible to activate this engine of walking, as we call it.
So the body is really set up for over-determination,
yes,
in effect.
Yes, there is very high redundancy in the system, and many alternative pathways participate in generation of these movements, and they can do it all together or one at a time. Practically, we need we need to activate very few cells in order to get a kind of reliable and potent activation of the pattern generators that I told you about.
Okay.
And this is our luck, actually, because these pathways survive most of the possible spinal cord injuries that we know, and it is possible to get activity in spinal cord injury patients even with severe injuries, even with pathways that are not intact. There are alternative pathways.
Well, you talked to me about when they're even broken, you can get a pathway going.
Yes, exactly, because you can activate a set of cells in a spinal cord that project all the way to the lumbar region. However, there is an alternative pathway by which you activate a series of cells, one after the other, with short-range projections. And these short-range projections are actually adequate to form the activation, to elicit activation of the pattern generators, despite the fact that the continuity is interrupted, even in several places.
So it's like driving a car along a road and there's a big gap and you jump over it and jump over it.
Exactly.
The spinal
it's a kind of a serial recruitment of cells all the way to the network that we're interested in.
Well, you know, as a layman, and you watched all these results, you say, this is phenomenal. You work with the Canadian Foundation for Hansen Foundation, don't you?
No, I mean, I just met him.
Oh, you just met him, I see.
I met him during his visit in Israel.
I see. He hasn't given you any money yet from
not
the
yet.
foundation. But in any case, if you get the sense that the idea is right, that we can restore people in many, many cases to be able to partially walk or even in the future fully walk.
We can restore some of the functions, revive some of the networks because of this redundancy in the spinal cord. There are many pathways and many neurons that are involved, and if part of them is taken out of the game, the others can actually reach functional capacity in I mean, in cases of spinal cord injuries with incomplete thoracic injury, as I say, the success rate is rather high. And after the training that I
that you showed us earlier,
I mean, a substantial percent of the patients can regain some of their some of the motor functions that they lost following the injury.
Can you envision a day in which maybe 20 years, 30 years from now, in fact, most people, including ones with severed spines, will be able to walk? Somewhat.
Well,
or is that too optimistic?
This is pretty optimistic, and I don't want to create illusions. And it's important not to create illusions. I mean, we can definitely do more than we used to do in the past, and the rehabilitation of spinal cord injury patients has advanced tremendously in recent years, and the motor capacity or the motor function can be improved, and several things can be even tremendously improved. But despite all this, I mean, people will still be highly disabled by these injuries. But I believe that with the spinal cord research in different fields, I mean, stem cells, regeneration, this kind of training that we described, sensory-induced activation of the pattern generators, and several other forms of researches and training in different ways, we can definitely improve the status of the patients.
Well, Aaron, I want to really thank you for this interview, of course, but much more for this research. I think it's phenomenal. It just, if you're novice at this, it sort of blows your mind, because especially since when I went to medical school, we were taught, people, once this happens, you can never walk again. You can't do anything about it. Forget it. And that's not true. And so I thank you for your research.
To some extent, you're right, and thank you very much. And I really enjoy this kind of research, and I'll keep on going as much as I can.
Thanks again.